Welcome back. In the previous video, we summarized the concept of molarity and molality, and then we looked at a variant of the basic concept of molarity. Okay, now here's another basic variety of it, or variant of it. Okay, so in this case, let's say how much of the solid, say magnesium chloride is needed. Okay, here I'm being nice to actually give you the formula, but don't always count on it because I'm recording it live, so that's why if I written it, I had to go with it. How much of solid magnesium chloride is needed to make make a 500 ml and 0.3 molar solution. Now, if you notice, again, we're still playing around that same concept, which is this is just another variety of that pizza. All right. So how much of solid? Well, it can't be any more obvious than that. How much of solid? Typically, solids are measured in grams, milligrams, kilograms, etc. Right? But don't confuse this kilogram to the kilogram of solvent. That's a liquid. So I'm just going to pick grams and say, well, because that's what you probably used to in a molarity calculation, so grams. And what are we given? Well, we're given volume, and we're also given the actual molarity of the solution, right? Right. So let's write up our molarity, and I'm not going to write the definition over and over again. I'm just going to write the final unit. So this is, molarity is moles per liter, right? All right. There is no grams here. So if I can somehow isolate, remember, if you can somehow get moles and you want to go to grams, then we use the molar mass, right? If you have gram and you want to go to moles, then you still use the molar mass, right? So this is the basic knot of a molarity is moles over liter. And I know that number is 0.3. If I can somehow manage to extract just the moles out of the molarity, then I'd be able to get the molecular mass of magnesium or molar mass of magnesium chloride and get the grams and the problem solved. But before we do that, let's actually calculate the molar mass of MgCl2, something we will need. Magnesium is 24. So again, I'm just using round numbers. You can use the actual values that's shown in the periodic table. So I'm getting 94. So the molar mass of MgCl2 is 94 grams over 1 mole. Always get into the habit. You're not doing 1,000 problems on a test, only one problem. So you have the time to do this. Always write units and write them appropriately so it doesn't lead to any kind of confusion. Okay, so this is, first we got to get the moles before this can even be used, right? Over here, right here in this step. So we got to first get the moles. The only way we can get that is, again, as I said, I always treat, I'm going to treat this information as my given information. So it's 0.3, right? Moles over, well, we normally write 1, right? Well, here it's 1 liter, essentially, right? So just write 1 liter, right? That's my given information. The reason I'm writing the liter is for a reason. Normally I don't do it, I just write a 1. You could also write 0.3 m, but then you would never be able to see how the mole is there in the m. So, well, this is in liters, right? Well, whenever you write 0.3 molar, okay, that is same as writing 0.3 moles over 1 liter. That's what it really means, right? That's what I keep saying. And so we have to convert this 500 mils to a liter. And if you do the conversion, 1000 mils is 1 liter. So 500 mils would be 0.5 liters. So 0.5 liter goes to the top. There's nothing to put here, so just leave weight, put a 1. So this one and this one has a slightly different meaning. This one has a liter tag to it. There is a purpose to it. So let's go get our handy red pen. Okay, so the liter cancels out. Now we're left with moles. So 0.3 times 0.5. So it's 0.15 moles. Now I am at a place where I have essentially squeezed out just the moles out of the molarity. And that's exactly what I was going after. Now I know my moles, right? Now let's do another tic-tac-toe. Now this is my, you can do them all in one go, but when I teach somebody, I normally do it this way. As I said, if your comfort zone is, if you've understood it, then yeah, you don't need to do it the way. So I'm just going to put 1 because there's no information available. And I know the molar mass is 94 grams over mole. Whenever you want to go from moles to grams, moles must be got rid of. So 1 mole goes at the bottom and 94 grams goes at the top. So the moles can cancel out. So that times 94 leads to 14.1 grams. Right? This is just another variation of the same concept, right? Good. Now let's go to look at something else that I've been meaning to show you, and that is dilution. Okay. Okay. Okay, that is, say I have, okay, a test tube with a solution, some unknown solution X, okay, solution X. Okay, we don't need any specific, because the beauty about dilution is the concept is the same irrespective of what the substance is. So solution X would just work fine as solution Y or solution Z or A or B or C or sodium chloride, sodium sulfate, etc., etc. So the starting point of this is, say I have 0.5 molar of this, whatever the substance is in solution form, and I have, say, 500 mils of it. Okay, so I'm going to call this, say, that's not really 500 mils. I mean, you have to live with my artistic. So that is 0.5 molar and 500 mils. Okay, and I want the new concentration. I'm going to get a different color test tube. This is really important, because I think these are the two things when you work as a work study for a chemistry lab or chemistry stockroom. Again, I'm not saying you would have to be a chemistry major to do those jobs, but you have to know those basic calculations so that it'll, take you a long way in being very organized. All right, so this is what you're starting with. Okay, start, and in the end, your lab instructor or whoever you work with, your supervisor, might tell you, we have half a molar, 500 mils of the stock, and then actually, you know what, I want to call the stock so that, in relation to a job, I think stock, at least for a chemistry class, I think stock sounds a better word. So he tells you, I want 1,000 mils of, okay, 1,000 mils of 0.1 molar, because, undergraduate students do use up more than they had to when when they go get detergents, when they go get chemicals from the hood, they always bring way more, don't use all of it, and throw them back again in the waste container. So that means you need to make more of it, and you notice the concentration. So this is what the end product should look like. This is what your supervisor has requested you to do, is I want 1000 mils of 0.1 molar. This is what you start with. Now keep in mind, you have this 500 mils, right? Every drop is 0.5. Okay, so when you do dilution, so essentially you're only focusing on three things. What do I have to start with? And where do I have to end up? How much of the volume you start with only becomes important when you're really in short supply, okay? But we're not going to look at those cases because we're not really running a stock room here. We're just learning a concept, right? So how much you have to start with is of least concern for dilution problems, because like I said, whether you take 2 drops from it and measure its concentration, or you take 10 drops, say 1 drop, that's a really badly drawn droplet. So this is also will be 0.5 molar. If you can get actually a drop, or you take 2 drops, that will also be 0.5 molar. That's the beauty of science, okay? Doesn't change because you go to a different city, different state, different university, different country. Well, the idea is essentially the same, okay? Every drop in this 500 is 0.5. That's why I said how much you have to start with should be of less concern to you. It is what your concentration you're starting with, and what's the volume you needed, and what is the final concentration you need. Okay, so I'm going to call my stock concentration as, V stock, okay? And this is my end volume of my container, so I'm going to call it V end, and then my final end concentration is, I'm going to call it concentration and C end, okay? So you're just doing a dilution. As I said, this concept is the same whether you're dealing with solution X, B, C, etc., etc. So there's a simple formula, which is V stock times C stock, because we have to find out how much we have to take out of this 500 of this 0.5 to make this. So we need both. This is what we're ultimately calculating, because we already know the end volume and concentration. This volume has no bearing, okay? So V stock times C stock equals V end times C end. This is a formula that I don't want you to forget if you're planning on taking any chemistry or any kind of science class. They will come back, and I think if you're going to be a nursing major too, you need to know how to dilute. Some of these concepts will appear in different names in a nursing test, but again, it'll be exact same thing. Okay, so we know the concentration of the stock is 0.5, right? Again, the beauty is don't need to convert any major things. You can leave them everything as it is. Volume of the end is 1000 mils. And concentration at the end is 0.1 molar. So that means V stock is basically 1000 times 0.1 divided by 0.5. Because these are molar, cancels out. You don't need to even do any conversions, not at this point, unless you're requested to provide the final answer in milliliters or liters. So I'm just going to do 1000 times 0.1 divided by 0.5. So that's 200. Okay. So all you are going to do is you are going to take, okay, I'm going to draw the This is where people make mistakes, okay? You need stock of 200, okay? So I am going to be consistent with the colors of my start and my end. So I'm going to take 200 mils of my stock, okay? This is that 0.5 molar, and I'm only going to take out 200 out of the 500 that I have in supply. Okay, now I want 1000. What students do is, well, this is the final volume. This is not how much you're going to add because you already have 200. So this is the reason why I'm doing this in color is the remainder 800. Okay. This is 800 mils of water that you're going to add to this 0.5 molar 200 mils, and then when you shake it, you will end up with 0.1 molar 1000. Please do not add 200 plus 1000. That means your new volume is 1200, okay, which means you'll be somewhere up here. And I don't want you to do that, because if your doctor tells you to dilute amoxicillin or penicillin to a certain concentration, you don't want to dilute it too much that the patient has absolutely no effect from that dosage. Or the other way around, he's telling you to dilute and you're going to take too less to a point where you're going to concentrate it and make it hard for the patient, right? So the key here is the problem is just asking how much of the stock would you need. The answer is 200, okay? But I am going to extend this since I am here. I'm going to extend the question to how much water would need, how much of water had to be added. Well, we want 1000. We know we add 200 from the stock. So that means we have to add 800. So these are two different questions. Don't mix them up, all right? If I just ask you how much of the stock do you need, the answer is 200. If I ask how much of water had to be added to the stock to get the desired volume and concentration in the end, then that had to be 800. So this is all there is to a dilution problem. And hopefully I've shed some light, because you can't really graduate out of a chemistry class and not really know how to do a proper dilution. And again, because chemistry's stock rooms typically have jobs that nobody wants to deal with, because again, most people are afraid that the person will have them do these calculations before start of each lab session or week, and then your job is to prepare these stock you have to do the stock to the actual usage conversions, and most people are afraid to do that. Or they may be just afraid of chemicals, or maybe just afraid of being in a chemistry building. But either way, this is a very basic skill. If you know how to calculate molarity and the various variants we've looked at, the 3 other variants, and if you can do dilution, well, guess what? That makes you a very, very, very marketable product in a chemistry building. And if you're looking for a summer job as an intern, pay is not going to be great, but hey, it's something to say I have a job in the summer. And this would be a great place to showcase your mathematical talents by calculations and your finesse by transferring and making beautiful solutions for students to use. So if you don't know basic dilution and you're going to apply for a chemistry internship, you're going to have a real problem in your hand. And now I hope I have partly solved that problem, but unless you actually understand it, the problem's not completely solved. So go ahead and work it out. And then when I come back, I am going to teach you how to do dilutions. There might be a couple of videos between this and then the balancing chemical equations video. But again, that's because I'm recording this after, and I've already recorded those videos. So those are a little bit harder concepts. So if you can manage these, then that will seem a little bit more hard for you. But again, I've explained it thoroughly, so you should have no problems. Anyways, I will see you back with balancing chemical equations. So stay tuned.